2, 1.
Okay, today we're going to learn about trapezoids and kites. Now a trapezoid is a quadrilateral with one pair of parallel sides. With this being said, segment AB is parallel to segment CD. Now an isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. So this means that this side is congruent to this side, and this side is congruent to this side. Now a theorem we've learned with isosceles trapezoid is the base angles of an isosceles trapezoid are congruent. With a trapezoid having two bases, this means that the upper base is congruent to the opposite upper base, and the lower base is congruent to the lower base over here. Likewise, the upper base over here is congruent to the upper base over here, and the lower base over here is congruent to the lower base over here. With these definitions and theorems, we're going to work an example. First, we are to find the measure of angle D, the measure of angle C, and the measure of angle B, if ABCD is an isosceles trapezoid. Well, by definition of an isosceles trapezoid, we know that AB is parallel to segment CD. We also know that the measure of angle A is 105, which is given. Since angle A and angle C are supplementary angles, that means that their two angles measure up to 180 degrees. Given the value of measure of angle A, which is 105, we take 180 minus 105 degrees, and we get that the measure of angle C is 75 degrees. Because this angle is 75 degrees, and by definition we know that isosceles triangles have congruent base angles, we know that the measure of angle C is congruent to the measure of angle D. So we know that the measure of angle D is also 75 degrees. Also, by definition, we know that the measure of angle B is 105 degrees because it is a congruent angle to measure of angle A, which is given. So the measure of angle A is congruent to the measure of angle B. And since segment AB is parallel to segment CD, we know that all of these angles add up to equal 360 degrees. We also have another theorem dealing with isosceles trapezoids, that the diagonals of an isosceles trapezoid are congruent. This means that this diagonal is congruent to this diagonal, and likewise this diagonal is congruent to this diagonal. Now let's solve an example to see how these diagonals are congruent. This is given that the diagonal AC is equal to 2x minus 1, and the diagonal BD is equal to x plus 2. Well, by the theorem, we know that the diagonals are congruent, so 2x minus 1 must equal x plus 2. Here we are to solve for x, so we subtract x from each side, and we get that x minus 1 is equal to 2. If we add the 1 across, we get that x is equal to 3. And thus we have solved our answer. That is it mostly for trapezoids. Let's move on to kites. Now a kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. This means that this side is congruent to this side and this side is congruent to this side. Now let's solve an example using this definition. Find x and y if the kite TKBJ is a kite. So, by this definition we know that this side is congruent to this side and this side is congruent to this side. Well, we know here that x is the variable and x is the variable on this side, and y is the variable here and x is the variable here. So it would make sense to solve for x first, so that we can plug it in to find y. So here we have first 2x plus 4 is equal to 3x minus 5. If we subtract 2x on this side and subtract 2x on this side, we get that 4 is equal to x minus 5. And if we add 5 over, we get that x is equal to 9. Now, we must solve for the top. So 2y plus 5 is equal to x plus 6. Well, we know that x is equal to 9, so if we substitute that in, we get 9 plus 6 is equal to 2y plus 5. Well, 9 plus 6 is equal to 15. And 2y plus 5 is equal to 15. So if we subtract the 5 over, we get that 2y is equal to 10. And if we divide by 2, we get that y is equal to 5. So now we have solved for x and y. Now let's work one more example dealing with a kite so that we're sure we can do this. Here again we find that this side is congruent to this side and the top side is congruent to the top side. We have x here and a y here and an x here, so it would make sense to solve for x again. So you have 4x minus 3 is equal to 2x minus 1. If we subtract the 2x and subtract the 2x, we get that 2x minus 3 is equal to negative 1. If we add the 3 across, we get that 2x is equal to 2. And if we divide by 2, we get that x is equal to 1. Now, solving for y. We know that y minus 1 is equal to x plus 3. So then we substitute our 1 in for our x. So now y minus 1 is equal to 1 plus 3. So y minus 1 is equal to 4. And then if we add the 1 over, we get that y is equal to 5. So now we have solved for x and for y. And that is basically it for kites and quadrilaterals.